Now we will discuss about the topic of time division multiplexing. This is the subject of principle of communication. So what is the time division multiplexing role and what is the advantage and what is the disadvantage in communication of the TDM system? So what is the multiplexing? So multiplexing to refer to the combination of information streamed from multiple sources for transmission over a shared medium. Multiplexer is a mechanism that implement the concept in demultiplexing to refer to the separation of combination back into separate information stream. So the demultiplexer to refer to a mechanism that implement the concept. In figure illustrate the concept, each sender communication with a single receiver and all pairs share a single transmission medium. Multiplexer combine information from the sender for uh, transmission in such a way that the demultiplexer can separate the information for the receiver. So in the concept of multiplexing in which independent pairs of senders and receivers share a transmission medium. So in this diagram, there are different senders, sender 1, sender 2, and senders n. And these senders uh, transmit the information and apply to the these information to the multiplexer, and multiplexer convert into different senders into a single share medium. And after that, in the demultiplexer, the single channel or single share medium convert into the different channel or different receivers, just receiver 1, receiver 2, and so on, receiver n. So this is the concept of the multiplexing and TDM system. Need of multiplexing. What is the need of multiplexing in TDM system? Transmitting two or more signals simultaneously can be accomplished by setting of one transmitter receiver pair for each channel. What this is an expensive uh, approach. Next, a single cable or radio link can handle multiple signals simultaneously using a technique known as multiplexing. So this is the technique of multiplexing. In multiplexing permits hundreds or even thousands of signals to be combined and transmitted over a single medium. That is the process in multiplexing system. Cost saving can be gained by using a single channel to send multiple information signals. So there is a diagram of multiplexing and demultiplexing. In multiplexer, there are different multiple input signals, and multiplexer combine all inputs into a single channels. And single communication channel may be wire or radio. But in demultiplexer, the process input signals by sorting it out into the original individual signals, and the output of the demultiplexer is the different original input signal. So this is the uh, combination or function of the combined multiplexer and the demultiplexer. And this is also a multiplexing network, and we can explain it and understand it with the same as uh, multiplexing and demultiplexing concept. So there are different channels before transmitting, and after one line or uh, signals or channels are transmitted on the one lines, and at the output of the multiplexing there are different output of the multiplexing demultiplexing. So multiplexing convert many more signals into one channel or one signal, and demultiplexing convert one channel or one signal into more than one channel or more than one signals. So these are the some examples of multiplexers in typical point-to-point application using the fiber optic. This is the multiplexer, fiber optic multiplexer, in which different data or signal are transmitted through the multiplexing and reconverted into the original signal with the help of the multiplexing. So these are the examples of multiplexer and demultiplexers networks. This is the multiplexer device at on TSU-T1, and this is also multiplexing devices. The basic type of multiplexing, there are four basic approach to multiplexing that each have a set of variation and implementation. First one is the frequency division multiplexing FDM. Second one is the wavelength division multiplexing WDM. Third one is the time division multiplexing TDM. And fourth and last one is the code division multiplexing CDM. So TDM and FDM are widely used, and WDM is a form of FDM used for optical fibers. In CDM is a mathematical approach used in cell phone mechanism. So in frequency division multiplexer or FDM, there are channel separation of spectrums into smaller frequency bands, and channel gets bands of spectrum for the whole time. And there are some advantage of the FDM. In FDM, no dynamic coordinations needed. And next one is work also for analog signals. So this is the advantage of FDM. And some disadvantage also there. First disadvantage of this FDM is waste of bandwidth. Second is if traffic distributed unevenly. And next one is inflexible, and last disadvantage is the guard space. So there are some disadvantages of the FDM multiplexer systems. Each signal in FDM is allocated different frequency band usually used with analog signals. Modulation equipment is needed to move each signal to the required frequency band or channel. Multiple carriers are used, each in called subcarriers. So multiplexing equipment is needed to combine the modulated signals. The conceptual view of frequency division multiplexing as a providing a set of independent channels in this diagram, and there is the function of multiplexer and demultiplexer in this diagram. There are different inputs to the multiplexer, sender 1, sender 2, and dot dot sender n. And also there are different uh, outputs of the demultiplexer. There are receiver 1, receiver 2, and so on. So this is the conceptual view of frequency division multiplexing as a providing a set of independent channels. This is also diagram show the different baseband analog signal into the FDM signals with the help of different modulator which have the different frequency F1, F2, and F3, and these are summing it the summing network, and output of the this summing network is the FDM process or FDM output. And this diagram show the FDM demultiplexing. So a FDM signal applied to the different filters 1, filter 2, and filter 3, and these filters output of these filters applied to the different um, demodulators which have the frequency F1, F2, and F3, and these demodulators convert the FDM signal to the original baseband analog signal. So this is the function of the FDM demultiplexing diagram. Next, we come on the time division TDM system multiplexing. And what is the TDM? So TDM is the time interleaving of samples from several sources so that the information from these sources can be transmitted serially over a single communication channel. At the transmitter, simultaneous transmission of several signals on a time sharing basis, and each signal occupy its own distinct time slot using all frequency for the duration of the transmission. At the receiver, the slot may be permanently assigned on demand, and demodulators or sampler has to be synchronized with the incoming waveform. And in frame synchronization, so there is a low pass filter and pure poor channel filtering and feed through of one channel signal into another channel. So in crosstalk application of TDM, digital telephony, data communication, satellite access, cellular radio. So these are the application of TDM. In this diagram, the different message inputs are applied to the low pass filter, and these outputs of low pass filter applied to the commutator, and then after these transmitted on a communication channel, and at the point of receiving or receiver, the demodulator convert into this communication signal with the help of different low pass filter into the output signal, that is the output of the demodulators. And this diagram also a simple rotary switch multiplexer system. There is a analog signal is applied to the multiplexing network, and there is a rotary switch. With the help of rotary switch, the input signal convert into the uh, different multiplex output. So this is the simple rotary switch multiplexer. In TDM, usually used with digital signal or analog signals, and also carrying digital data. Data from various sources are carried in repetitive frames. Each frame consists of a set of time slots. Each source is assigned one or more time slots as per frame. So this is in the TDM system. There are different input signals multiplexed and transmitted in the form of data, that is the 1 2 3 and so on, and the output of the after demultiplexing of this data, the output of demultiplexer is the uh, receiver 1, receiver 2 and so on. So this is the data uh, from various sources and carried in the repetitive frames. In TDM, composition of one frame of a multiplex pulse amplitude modulation signal incorporating 4 voice signals and a synchronized pulse, that is the shown in this figure. There are 4 different voice channels, and a composition of one frame of a multiplex PAM signal incorporate 4 voice signals and synchronous pulses. So there is a one sampling period Ts equal to 125 millisecond of these voice channels. In TDM, the conceptual diagram of multiplexing and demultiplexing. So this is the conceptual diagram of multiplexing and demultiplexing. There is the different input channels or data source applied to the multiplexer and then transmitted at the high speed on a transmission over the transmission line. And next, these signals is demultiplex, and after demultiplexing, at the destination point there is the different output signal, signal 1, signal 2 and so on. And an PAM TDM system, so there is a low anti-aliasing filters, that is the low pass filter, and there are different message input signals, and these signals applied through the low pass filter to the commutator, and after the commutator applied these signals into pulse modulators and also a clock pulse applied to the pulse modulator, and then communication channels, and then applied to the next pulse demodulators, and a clock pulse is also applied to the pulse demodulator, and again this channel applied to the D commutator, and after the D commutator there is a low pass different filters, and the output of these filters, that is the output message signal, message 1, message 2 and message 3 and so on. So this is the conceptual diagram of multiplexing and demultiplexing. So this is the 4-channel PAM TDM multiplexing. 4 different analog signals can be sampled by the PAM multiplexer as shown in these diagrams. Signal A and C are continuously very analog signals, and signal B is a positive going linear ramp, and also the signal D is a constant DC voltage. So there are the 4-channel PM TDM multiplexing systems. Block diagram of TDM system. So this is the block diagram of a typical framing structure for the TDM. So this shows the different stage of in this diagram. There is the low pass filter, commutator, pulse modulator, communication channel, pulse demodulator, and clock pulse, and also decommutator, and different outputs of the different low pass filter. So that is the typical frame structure for TDM. In this diagram also there is a frame structure of a certain TDM system or TDM signal, and also composite signal format in the diagram of V. So in PCM TDM system, there is a block diagram of PCM TDM system. So a analog input signal which have the frequency 0 to 4 kilohertz, that is the channel 1, and another signal, that is the analog input signal which also have the frequency 0 to 4 kilohertz, that is the channel 2. And these channels and signals apply to the anti-aliasing filters, and output of these filters is also a sinusoidal signals, and this signal applied to the sample and hold circuits, and also a sample pulse of 8 kilohertz is also applied to these sample and hold circuits. And after of these two hold and sample circuit will be PAM, and this PAM applied to the analog to digital converter, and also a conversion clock applied to the analog to digital converter networks. And so this analog to digital convert the parallel PCM code, and these parallel PCM codes apply to the parallel to serial converter. And after the parallel to serial converter, also there a line speed clock applied at the 128 kilohertz, and the output of parallel to serial converter of both are 8-bit serial PCM code or 64 kilobit per second. These are applied to the TDM multiplexer, and the output of this TDM multiplexer is the 120 kilobit per second PCM TDM in the form of pulse. So this is the PCM TDM explanation with the help of diagram. In this diagram, a time division multiplexer used to produce pulse amplitude modulation. So there are some different analog inputs which is applied to the different MOSFET switch, and these MOSFET switch also uh, applied by the gate AND gate decoders in the form of digitals, and these gates also applied the input of these AND gates one slot or with the help of clock pulse, and output of these MOSFET switch applied to the summer amplifier, and output of this summer amplifier is again applied to the integrator, and after the integration the output of this integrator is the multiplex output. So this is the a time division multiplexer used to produce pulse amplitude modulations. There are different waveforms for the PAM multiplexer or pulse amplitude multiplexer. So there are some clock pulse waveforms, and some ones sound, and second one is the uh, gate outputs, and these are the waveform for the PAM multiplexers. Next, a PAM demultiplexer. So in demultiplexer, a modulated PAM signal applied to the different MOSFET device with the help of different resistance network, and the also MOSFET is feed or the uh, applied in different inputs with the help of AND gates and clock pulse and one zoom, and the output of these MOSFET applied to the different op-amp, that is the 4 to 1 to 4 decoders, and the different outputs of these op-amp operational amplifier to apply different low pass filter, and the output of these different low pass filter is the reconverted analog signal. So in this a modulated signal convert into the reconvert into the analog or original signal in the a PAMD multiplexer system. Next one is the, now we discuss about the synchronous TDM. So in this synchronous TDM is a broad concept that appears in many forms. It is widely used throughout the internet. Figures show the items being sent in a round robin fashion. Most TDM works this way. No gap occurs between bits of communication system uses synchronous transmission. When TDM is applied to synchronous network, no gap occurs between items. The result is known as a synchronous TDM. The figure illustrates how synchronous TDM work for a system of 4 senders. So this is the synchronous TDM diagram. Illustration of a synchronous time division multiplexing system with 4 senders in this diagram. There is 4 senders, senders 1, 2, 3, and 4, and that is multiplexed and transmitted in the form of data on a single channel, and these again demultiplex and original signal converted into the modulated signal converted into the original signal, and the form of different outputs 1, output 2, and outputs 4. Now synchronous time division multiplexing system, the medium exceed data rate of digital signal to be transmitted and multiple digital signal interleave in time. Also maybe 8-bit level of blocks and time slot pre-assigned to source and fix. So the time slot allocate even if no data, and a time slot do not have to be evenly distributed among sources. In telephone system, use synchronous TDM to multiplex digital stream from multiple phone calls. They use the acronym TDM to refer to the specific form of TDM used to multiplex digital telephone calls. So the phone system TDM includes an interesting technique to ensure that demultiplexer stays synchronized with the multiplexer. And why is synchronization needed? So we observe that a synchronous TDM sends one slot after another without any indication of the output to which a given slot occurs. So a demultiplexer cannot tell where a slot begins. A slight difference in the clocks used to time bit can cause a multiplexer to misinterpret the bit stream. To prevent misinterpretation, the version of TDM used in the phone system includes an extra framing channel as input. Instead of taking a complete slot, framing insert a single bit in the stream on each round. So a demultiplexer extracts data from the framing channel and check the alternating 0 and 1 bit. And if a error causes a demultiplexer to lose a bit, so it is highly likely that the framing check will detect the error and allow the transmission to be restarted. So framing used in the telephone system version of TDM. So this is the TDM system used by the telephone system in which a framing bit precedes each round of slots. So this is the framing used in the telephone system version of the TDM. So some problem with the synchronous TDM, which is unfilled slots, and synchronous TDM work well if each source produce data at a uniform fixed rate equal to 1 upon n of the capacity of the shared medium. The many sources generate data in burst with the ideal time between bursts. To understand why, consider the example in figure. On the left, to source data item at random, the synchronous multiplexer leaves a slot unfilled. If the corresponding source has not produced an item by the time, the slot must be sent. In practice, a slot cannot be empty because the underlying system must continue to transmit data. The slot is assigned a value such as 0 and an extra bit is set to indicate that the value is invalid. So in this diagram, synchronous TDM system leaving slots unfilled when a source does not have a data item ready in a time. Now, asynchronous TDM or statistical TDM. In asynchronous TDM or statistical TDM is designed to avoid the waste of synchronous TDM. The term asynchronous means flexible, not fixed year. In asynchronous system, if we have n input lines, the frame contains a number of at least n time slots. So in asynchronous system, if we have n lines, the frame contains no more than m slots with m less than n. In this way, asynchronous TDM supports the same number of lines as synchronous with a lower capacity link, or given the same link asynchronous TDM can support more devices than synchronous TDM. So in the asynchronous TDM, how can a multiplexing system make better use a shared medium? One technique to increase the overall data rate is known as statistical TDM or asynchronous TDM. Some literature use the term asynchronous TDM. The technique is straightforward. Select item for transmission in a round robin fashion. What instead of leaving slot unfilled, skip any source that does not have data ready. By eliminating unused slots, so asynchronous TDM takes less time to send the same amount of data. Figure illustrate how a asynchronous TDM system send the data from figure in only 8 slots instead of 12. So this is the block diagram. So the how statistical multiplexing avoid unfilled slot and takes less time to send data. So this is the diagram of asynchronous TDM. In asynchronous multiplexing, incur extra overhead, which is considered demultiplexing. In a asynchronous TDM system, a demultiplexer knows that every n slot corresponds to a given receiver. In a statistical multiplexing system, the data in a given slot can correspond to any receiver. So each slot must contain the identification of the receiver to which the data is being sent. The output data rate less than aggregate input rates. So may cause problem during peak period. Buffer inputs, keep buffer size, keep buffer size to minimum to reduce delay. So here are the comparison between synchronous TDM and statistical TDM. So there is in synchronous time division multiplexing different A1, B1, C1, D1, A2, B2, C2, D2, where A1, B1, B2, C2 is the data, and statistical time division multiplexing first cycle and also there is second cycle, and there is the A1, B1, B2, C2 and unused capacity, where is the some slots show the address and some show the unused capacity, and there are different users A, B, C, D and different time slots here, and to these connect to the remote computer. So this is the synchronous TDM and statistical TDM comparison. Now we discuss about the T1 carrier system. What is the T1 carrier system? A T1 carrier is a dedicated telephone connection or time division multiplex digital transmission service that support a data rate of 1.544 megabit per second. A T1 line generally includes 24 separate channels, each of which is able to support 64 kilobit per second. Every 64 kilobit channels is often customized to transport voice or data traffic. The majority of telephone companies only allow the purchase of a few of the individual channels referred to as a fractional T1 access. The T carriers systems are totally digital and use time division multiplexing TDM and pulse code modulation PCM. The original T carrier system was developed by Bell Labs in the early 1960s. So this is the Smart Jet Network interface device, which is the for use a T1 circuits. The T1 system, which carries 24 voice channels over separate pairs of wires with regenerative, repetitive, and each of the 24 voice channels use a binary code with an 8-bit word. The first bit indicates whether the input voice sample is positive or first is 0, negative, 0. The next 3 bit of the code word identify a particular segment inside which the amplitude of the input voice sample lies, and the last 4 bit identify the actual presentation level inside the segment. So with a sample rate of 8 kilohertz, each frame of the multiplex signals occupied a period of 125 microseconds. In particular, it consists of 24 8-bit words plus a single bit that is added at the end of the frame for the purpose of synchronization. Hence, each frame consists of a total of 24 multiply 8 plus 1 equal to 193 bits. Correspondingly, the duration of each bit equals 0.647 microsecond and the resulting transmission rate is 1.544 megabit per second. So this is also a TDM block diagram. T1 is the method that is conventionally used by the telephone companies for transporting digitized telephone communication among central offices. Since the in 1960, a single T1 channel was able to carry 24 high-quality voice conversions. Because T1 is fully digital, it indicates the change of crosstalk, which is typically among analog carriers networks, where the copper pairs tend to pick up transmission from advantage of TDM. So there are some advantage of time division multiplexing system. A full available channels bandwidth can be utilized for each channel. So this is the advantage of TDM. Next one is the intermodulation distortion is absent in this TDM. And also TDM circuitry is not very complex. And next advantage, the problem of crosstalk is not severe. Only one carrier in the medium at any time. And next advantage, throughput high even for many users. So there are some advantage of TDM systems. So this is there are some reference books which covers of this topics, and the first book is Principle of Communication by B.P. Lathi, and second one is the Digital Communication by the T.L. Singles. And there are some multi-choice questions. The question number first, the positive RF peak of an AM voltage rise to maximum value of 20 volt and drop A to minimum value of 4 volt. So modulation index assuming single tone modulation is 3, 1 by 3, 1 by 4 and 1 by 2. So correct answer is the D, that is the 1 by 2. And like this, the second question, the most suitable method for detecting a modulated signal and 2.5 plus 5 cos omega mt and cos omega ct into 2.5 5 cos omega mt cos omega ct is the option A, envelope detector, option B, synchronous detector, option C, ratio detector, and option D, both envelope detector and synchronous detector. So correct option here is the option B, synchronous detectors. So these are the some multi-choice question. And in this question, a product modulator yields option A full AM signal, option B, a DSB SC signal, option C, a BSB signals, and option D, a SSB signal. So in product modulator, yields means that is the single sideband signal. So correct answer is option D. And in next question, a FM signal can be detected by using option A and low pass filter, option B a band pass filter, option C a discriminator, and option D is a average detector. So here the correct option and correct answer is option B, is the band pass filter. So these are the some important and very interesting multi-choice question. So thank you very much.